Alright people, in this video I'm going to review some basics of statistics, in particular standard deviation and normal distribution. So let's first talk about normal distribution. This comes with a very basic and easy idea of tossing a coin. Let's say if you are tossing a coin, there's a 50% chance of getting a head and a 50% chance of getting a tail, right? 50-50, half-half. So let's assume if you get a head, you would earn $1. If you get a tail, you will lose $1. So that's a +1, -1 here, right? So what is your expected value? Well, if you want to get the expected return here, then you would use 50% times +1 plus 50% times -1. So that will be 0. And if you look at the distribution chart, it is more likely to be this. So this is your chart. The probability here is 50, and here is a -1, here is a +1. All right, so that's going to be your distribution chart. Now, let me just tell you, this time I'm going to toss my coin twice. If I toss my coin twice, so there will be 4 possible outcomes. The first outcome is +1, -1, second outcome, -1, +1, and then +1, +1, -1, -1. And they all come with a certain probability of 25%. You all agree with that, right? So this 35%, all of them equals to 50 times 50. All right, you do the toss coin job twice. And if that's the case, then you would end up with 3 possible outcomes. So this is 0, this is -2, this is a +2, and this is 0. So you will get a 50% chance of getting a 0 and a 25% of a +2, 25% of +2. All right, so no doubt with that. If you draw a distribution chart, it will go like this. This is your probability, and this is your outcome. So you will have 25% of getting -2, 25% of getting +2, 25%, 50% of getting 0. All right, you can see that from this chart. This you just do it once, and right here you do it twice. All right. So if you keep tossing a coin, if you do it 3 times, and I can tell you, if you do it 3 times, the distribution will look like this. So you have 4 possible outcomes. The 4 possible outcomes could be +1, +3, okay, -1, and -3. If you do the tossing coin 3 times. So how do you get a +1? So you get +1, +1, -1, all right, or +1, -1, +1, or -1, +1, +1, right? And this comes with 3/8 of a probability. This comes with 1/8 of probability. All right. So if you keep tossing the coin for millions of times, as you can see here, how your distribution star look like, and then it goes like this, you will see it's more spread out than concentrated. So if you do it 4 times, it will go like this. So in the middle you have a 0, and then you have a +2, you have a +4, then you have a -2, you have a -4. Your distribution will go like this if you do it 4 times. If you do it 1,000,000 times, then you will see it will be more spread out, and the shape will be more also concentrated in the middle. So if you do it 1,000,000 times, it will go like a camelback shape. You know, camels, right? So it will go like a camelback shape. And this is a normal distribution. Okay, this is normal distribution. So the expected value of normal distribution from this game is 0. And you will have a standard deviation. Let's say if you calculate the standard deviation is 1, all right? Standard deviation is 1. So once again, standard deviation comes from each possible return minus the expected 0, and then take the square, then multiply by the probability, then sum them up, then take the square root. Okay, let's just skip that tough formula for standard deviation, just to take that as 1. All right. So if it's a normal distribution, as we know, this comes from millions and millions of times of tossing coins, and then we summarize all the possible returns and their associated probabilities. So that's your normal distribution. Now what I want to tell you here is under the assumption of a normal distribution, which is a randomness. Okay? When you toss a coin, randomly you get a tail, randomly you get a head. So randomly you would get a positive 1, randomly you would get a negative 1. So that's randomness assumption. So under this assumption, if your value, let's say, if you want to find a value that is between 1, positive 1 here, and a negative 1 here, so this is 1 standard deviation away from your expected value, given that your standard deviation is 1, right? Standard deviation is 1, this is 1 standard deviation up from the expected, this is 1 standard deviation down from the expected. And you have a lot of values here. So either negative 0.9, negative 0.8, positive 5, positive 4, so on and so forth. So for these values, what's their total probability of occurrence? This probability, okay, after you do the calculation, is a 67%. Okay, so that means 67% of your possible outcomes will be allocated between negative 1 and a positive 1, given that, or you can say it, negative standard deviation or positive standard deviation. So 67% of your possible outcomes, millions and millions of outcomes, will be allocated right here, okay, between negative standard deviation away and a positive standard deviation away. And if you do 2 standard deviations, okay, 2 and a negative 2, so that is going to occupy 95% of your all total values, okay? So that's going to be 95% of your total value will be located between negative 2 and a positive 2. So it's very unlikely, or only up to 5% likelihood, the extreme values will be right here, okay, like above 2 or below 2. So for them to happen is only under 5% probability. Still, there's some possibility for them to happen. And if I do the further extension, let's say I'm going to do a positive 3 here, and then a negative 3 here. All right, so let me just extend this. So the probability for my value to happen, okay, between negative 3 all the way to positive 3, that's a 99%. Okay, so under this normal distribution, for your value to happen between negative 3 and a positive 3, which both of them, both negative 3 and a positive 3, would be a very extreme number, and it is quite unlikely for any return to happen here, any return to happen here. All right, so for let's say if you have a negative 4 happening here, it's gonna be less than 1%. Okay, if you have a positive 6 to happen here, it's gonna be much less than 1%. So here are some numbers I want you guys to remember. So 1 standard deviation away, okay, 1 standard deviation away, so that's a 67% of your total values, total possible outcomes. And for 2 standard deviation away, that's 95%. And 3 standard deviation away, that covers 99%. All right. In one of your report, which is about Yale Endowment Fund, the manager actually introduced you an event happened in 1987. We call it Black Monday. And in that event, the stock market drops by a very, very large number, okay, down to the left. Okay, so it's a very negative number, and that number is a 6 standard deviation away. Okay, so that's a 6 standard deviation away. If we assume normal distribution, for a value to happen right here, it is going to be like under 1/1,000,000th of percent. So it's a very, very unlikely. So what happened on that Monday in 1987? Is that really a event based on normal distribution, based on randomness, or is our basic assumption of the market is wrong? Should we assume the market goes like a random distribution, just come up with millions and millions of tossing coins? So that's really a big dispute in the current market. So anyways, this is something required for my class, and you should know all these numbers for your report in the yield endowment fund.